So I thought that I would skip the schema evaluation part, but I think it's pretty important that I cover it because schema evaluation is one of the prevalent operation that happens in data warehousing systems. And how do you do schema evaluation on Athena? So in Athena, when you talk about schema evaluation, basically what happens is that the underlying file changes, then you alter the metadata in the glue data catalog. And this is what we are going to do. I'll be creating a table order underscore items in a different database with very small data, I think around 10 rows. So initially the table would have only order ID and product ID, and it will point to a folder called schema1 where I'll put the file which would contain order ID and folder product ID. Then I'll add order date. Now after adding order date, the schema would look like this: order ID, product ID, and order date. And it would point to a folder called schema2 because it would contain records with order date here. Then in the third part, we'll change the column position for product ID. So what will I do is that I'll move order date from third position to second and product ID from second position to third. And this table will point to another folder called schema3. And the data would be as per order ID, order date, and product ID. After everything is done, what will I do is I'll keep all the files in one place and I'll show you how the behavior is during schema evaluation. And then drop column, I'll not show you drop column because it's supported only for Iceberg tables. We'll talk about Iceberg tables shortly. Also, I thought that let me show you how to query JSON and when you store the JSON as string. So these are the two main functions, and basically this is the main function, JSON underscore extract. Using this extract, you can actually get the JSON columns, nested columns, which are stored as string. So first let me go ahead and do this. I'm creating a database named schema evaluation DB. So this is the name of the database. Currently I have only 3 IAM DB and default. So the database has been created, as you can see, schema evaluation DB, and of course it does not have any table and does not have any views. And what I have done is that there's a folder called schema evaluation. In this particular folder, there are again 3 subfolders: order items Avro, order items CSV, and order items Parquet. And in order items Avro, you have schema 1, schema 2, schema 3, where it is as per the first schema. Schema 2 contains Avro file as per the second schema after adding order date, and third one contains the record as per the third schema. Same is the case with CSV and Parquet. So in Parquet also have schema 1, schema 2, schema 3, and finally I have schema all, wherein I have put all the files in one particular folder. So this first file contains only order ID and product ID. The second one contains order ID, product ID, and order date, and the third file contains order ID, then order date, and then product ID. So I'll not show you this using Avro because the behavior would be similar. And in CSV also have done the same. So I have schema 1, schema 2, schema 3, and then schema all. So first, let me go ahead and create the tables. So this is the CSV table, order item CSV with order ID and product ID. And the location is order items CSV schema underscore 1. And after this also I'll select records from this particular schema, from this particular table, sorry. So first let me execute this. So the table has been created. Now let me run a select statement. So the header has also been considered as a row, it seems, so which is fine because both are string. I'll not change it because the purpose here is to show you the schema evaluation. So now what will I do? I'll change the column name. So what am I doing here is that the order ID would be order ID and product ID would be changed to product code. So the replace column command would change the name of the columns, which should be okay in CSV. So after it is executed, this product ID should be changed to product code. As you can see, it has been changed. Now I'm changing the data type also. For the order ID data type has been changed to integer, and product code data type has been changed to integer. Now if I run select star from order items CSV, because both are integer, and remember that Athena is schema on read, so basically the schema is enforced while reading the data. So now here what happened, all the records are fine, but the first one, we cannot see the first record, because what happened, the deserializer could not convert it to Athena representation, because in Athena representation the database is, sorry, the definition is integer, but data is actually in string. So that's why the problem is. So it's fine, I'm not going to fix this right now. The next thing that I'm going to do is that I'm going to add a column. So alter table, add columns, order date, string. So let me run this, and order date should be added here automatically. So order date has been added. Now if I do a select star with the existing data, because existing one is pointing to schema underscore 1, so order date would be blank because there is no data here. There is no data for the column order date. So that's why what we can do is we can change the location also using alter table command. So let me change the location. So the command is again alter table and then set location, and I'll put the schema 2 folder here. Now why schema 2? Because schema 2 has order date column also. Now if I run this and then execute the select star again, I should be able to see values in order date. Now here it is string, so I can see the order date. The header was again not was considered as data. Of course, I'm not going to fix it as of now. So as you can see, when it was pointing to schema 1, order date was blank because the file did not have any record for schema 1, right? So that was the problem. And in schema 2, the file actually contains order date. I will change the position of the columns, and the command is alter table change column. So what am I doing is I'm changing the column order date, whose data type is order date and string, after order ID. So I'll be moving order date after order ID, and product code would be moved to the last. Now let me execute this, and it should change here. Okay, so as you can see, order date is second now and product code is third now. Let me run select star, because now remember that even now it points to schema 2. On schema 2, I have the file as per order ID or a product code and order date. Now, if I run it, I should see a lot of blanks. See, there is no product code anymore, and order date is 5111827 and product ID. Now, of course, it is working with order date because order date is string, so that's why I'm seeing the value. But product code is integer, and the data actually that we have is date, so that's why it is not showing anything. The representation or the deserialization was not done. Now if I change it to schema 3 folder, which contains records as per this order ID, order date, and then product code, so it is done now. Now I should be able to see record in all the places. So as you can see, we have order ID, proper order date, and product code. So product order ID and product code are blank because these are strings and we have integer here. Now finally, what am I going to do is that I will alter the location again with schema all, wherein we have all the files. Now remember this, now currently the table definition is order ID followed by order date followed by product code. Now in schema all, I have three different types of files. So if I go to schema all in the CSV, the first file has only order ID and product ID. The second file has order ID, product code, and order date. And the third one has order ID, order date, and product code. So now if I change the location, alter the location and run select star again, for some rows it will be correct, for some rows it will not be correct. So of course this is the first one. So this is actually the product ID. So this is the first file. Then this is the second file, and this is the third file. Of course, you cannot see any record in second file because it was jumbled up, right? So This is actually order date, so we are seeing product ID here. And now here we have correct file. So what does that tell you? It means that it's okay if you change columns, if you evolve the schema. You can add columns, you can remove columns, you can drop columns in case of iceberg tables. But what would happen is that the schema should conform to the data that you have, or the files that you have in S3. If the file is not as per the schema, then you'll see very wrong value. That's why when you pointed to their correct location, everything was fine. But the moment we added schema underscore all, it created a problem because we have jumbled up files there. And it is true for Parquet and Avro file also. We have both Parquet and Avro file. Now the next thing that I want to show you is basically saving JSON as string. So this is the table definition. So orders JSON as string, and I'm pointing to the same orders underscore JSON location which I had used to create the JSON orders underscore JSON table in the other database. So it has been successful. Now if I do a select star, so as you can see, the output is basically a single column with JSON data like this, which is basically the entire JSON document for each row. Now we can store it like this, and then we can retrieve it using JSON parse function, or rather JSON extract function. So what will I do is I'll select order ID, so JSON underscore extract, and here what I have to do is that I'll have to pass the data, which is JSON underscore data, and then in single quote I'll have to pass dollar first, or dollar dot first, which means that it's a JSON document. And then let's say I want to get the order ID, and I will write it as order ID, and then again JSON extract. Let me extract the order date, so start dot order date, because it is at level 1. Now let me try to get customer address and the address inside of it. So how do you do it? Again, JSON extract JSON data, and then followed by dollar dot. So I'll have to get the customer address, and then dot, again I'm using the dot notation, dot address as address. So this first dollar dot is essentially saying that this is a JSON document, so I'm starting from here. So this is the whatever I mention after this. The first one would be the first level, the second one would be the second level, so on and so forth. Now let me try to get the phone number also that we had extracted. So JSON underscore data dollar dot customer address, then phone, then not a box. I want to get the first element, so it should be dot one as. So this is how you can actually store the JSON data string and then extract it. But as I said, as a best practice, you should use the struct data type, which we had used earlier. So now if I execute this, it should execute in some time and then get us the record. But as I said, right, so as you can see, we have order ID, order date, address, and mobile phone. As a best practice, you should store it as the struct data type. Now here all the output is basically string. Okay, so that's about it. Thanks for watching.